Today we're looking at solving quadratics by completing the square. So we're going to be given a problem that has not been factored, and our goal is to try to get it to where we have a perfect square on one side and a number on the other. And so let's first off just kind of review what a perfect square trinomial is. And that's whenever you have where you can take the square root of both sides. And so what it is when it factors, it's going to be like x plus 3 squared. And so you know you have a perfect square trinomial. If you remember going back to what we're used to with put it in ax squared plus bx plus c equals 0. If the square root of c times 2 is equal to your middle number, then it's a perfect square trinomial. And so let's practice with a couple of these. So we want to do 2 times the square root of our 4 from here. Does that equal the absolute value of the 4 from there? Well, square root of 4 is 2. So 2 times 2 does equal, so that means we can use this format. And so you're going to do x, drop this sign, and then you'll take 4 divided by 2, and that gives us 2. And that's it factored. So let's do it again over here. We want to know is 2 times the square root of 100 equal to the absolute value of negative 20. And if that's true, then we can factor it this method. So 2 times 20 or times 10 equals 20. So that is true. So that means when I factor it, I do x, that middle sign, and negative 20 divided by 2 gives me 10. And then squared. And then that's the answer. Two more just like this. Again, we're going to check is 2 times the square root of 49 equal to the absolute value of negative 14. And so 2 times 7 is equal to 14, and that is true. So that means I can factor it using the shortcut method of x, this middle sign, you take negative 14, or take 14 divided by 2, and that gives you 7, and then that's your factoring. Okay, let's do it one more time. We take this 2 times the square root of 64. Does that equal the absolute value of 16? So 2 times 8. Does that equal 16? And that's true. So that means I can use a shortcut method to factor. So x, and then 16 divided by 2 is 8, and that middle sign. And that's the answer. So when you're just having to factor that perfect square trinomial, that's the method you're going to use each time. So now, let's look at it whenever we actually have to solve something. And so we're going to do the same thing. We're going to look at our left-hand side. And is 2 times the square root of 49 equal to the absolute value of 14? And so 2 times 7 is 14. So that checks out. So that means I can factor it with that shortcut. So x, my middle sign, 14 divided by 2 is 7. squared is equal to 4. Now, what I want to do is take the square root of both sides. And so I end up with x plus 7 is equal to plus or minus 2. So now I need to solve for x. So that means that I am going to subtract 7 from both sides. And so I have x is equal to negative 7 plus or minus 2. Because remember, when you take a square root, you're always going to have that plus or minus. At this point, since there are no square roots left in the problem, that means I need to come up with the two solutions that this is equal to. Negative 7 plus 2 and negative 7 minus 2. Negative 7 plus 2 is negative 5. Negative 7 minus 2 is negative 9. And so x is equal to the solution set in order from least to greatest, negative 9, comma, negative 5. Okay, let's do it again using this next one. And so we want to see, is the square root of, is 2 times the square root of 9 equal to the absolute value of negative 6? So 2 times 3 is equal to negative 6, or equal to positive 6, and that is true. So that means I factor it. It's going to be x, because the square root is first, and we have negative 6 divided by 2 gives me negative 3, which is what I put next, is equal to 20. So now when I take the square root of both sides, I end up with x minus 3 on the left-hand side, but I need to think about that 20. What perfect squares live inside of 20? We have 4 is a perfect square. And so square root of 4 times square root of 5. So 2 square roots of 5. But since we took the square root, it's going to be plus or minus. Now, I need to add that 3 to both sides. And this time, since there's a square root involved, I can't combine those. So I have 3 plus or minus 2 square roots of 5. And so my answer is x equals the solution set of 3 plus or minus 2 square roots of 5. And so that's ones that are already set up for us. But not all our problems are going to be this simple. Most of them we're going to have to do what's called completing the square. Thinking back to when we were talking about finding the vertex form, we're going to do the same idea, but this time we're going to be doing it for solving the quadratics. And so the first step is we need to rewrite it to where your constant is on the right-hand side. So in other words, this negative 34 needs to be moved to the right-hand side. And anything with a variable needs to be on the left-hand side. So when we move that negative 34 to the other side, it becomes a positive 34. And so we have x squared plus 8x is equal to 34. Now, you look in front of your squared. Is there a number more than 1? If so, you would divide. And so we don't have it, so we're done with this step. We've completed that step because there's nothing there to divide. Now we need to take and find that number that it's talking about here by half of b, so 8 divided by 2, and squaring it. So that's 4 squared. We're going to add 16 to both sides. And so we have x squared plus 8x plus 16 on the left-hand side and a positive 50 on the right. And so now we're going to go back to what we just had. We now have it looking like you did on numbers 1 and 2. So now we're going to take and factor it. So we have x, this middle sign. We've already done the work up here. So what's 8 divided by 2? 4. Is equal to 50. And so now we've added that to both sides. We have now factored the trinomial. The next step says take the square root of both sides. So when I take the square root of both sides, I end up with x plus 4 on the left-hand side. And I have to think about 50. I know it's going to have a plus or minus, but is there any perfect squares that live inside of 50? Well, square root of 25 times the square root of 2. The square root of 25 is 5. I can't take the square root of 2, so 5 square roots of 2. So plus or minus 5 square roots of 2. Now I need to move the 4 to the right-hand side by subtracting it. And so I have x is equal to negative 4 plus or minus 5 square roots of 2. And so I have now solved and simplified the solutions. And so my answer is x is equal to the solution set, negative 4 plus or minus 5 square roots of 2. And so we're going to do these for the different types of solutions that we have. And so we're going to practice with each of the different types. So the first one we're going to work with is just where it has rational solutions. That means there are no square roots involved. It can have fractions, it can have integer values, but it won't have square roots. And so I'm going to take and look and thinking about my steps. The first step is to get it to where this 56 is on the right-hand side. And so I have, x squared minus 18x is equal to a negative 56. So when I do this, I take negative 18 divided by 2 and I square it. So negative 9 squared is 81. So I add 81 to both sides. So when I add 81 to both sides, I end up with 25 on the right-hand side. And at the same time, I'm going to go ahead and factor the left, because I've already set it up in the perfect square format. So x, half of 18 we said was negative 9, so minus 9. Now I'm going to take the square root of both sides. And so remember, when I take the square root of an integer value, it becomes, or of a value, it becomes plus or minus that number. So we have x minus 9 is equal to plus or minus 5. So now I need to move the 9 to join the 5 by adding it to both sides. And so x is equal to 9 plus or minus 5. So that's a number without a square root. So what I'm going to do is I'm going to find the two different numbers, 9 plus 5 and 9 minus 5. Because we have plus or minus here. 9 plus 5 is 14. 9 minus 5 is 4. So when I write my solution, it's x equals the solution set 4, 14. Let's look at number 4. We already have that constant moved to the right-hand side, so that step's done. So now I just have to complete the square. So I need to take and go, what is negative, For one more step, we have a number that's not 1 here, so we need to divide everything by 2. And so we have x squared minus 8x equals negative 15. Now I'm going to take negative 8, divide it by 2, and square it. So that's going to be negative 4 squared, which is 16. That's what I'm adding to both sides. So plus 16 on both sides. And so when I factor the left-hand side, I end up with x is negative 4 squared is equal to 1. Now I'm going to take the square root of both sides. Square root of 1 is 1. So I have a plus or minus 1 over here on the right-hand side. We have x minus 4 on the left. I want to add the 4 to both sides. And so I have x is equal to 4 plus or minus 1. So I split it into my 2, 4 plus 1 and 4 minus 1. 4 plus 1 is 5, 4 minus 1 is 3. So when I write my solution as x equals, the smallest of those numbers is 3, the largest is 5. Let's look at number 5. So I already have my constant on the left-hand side. So now I divide everything by 4. And so I have x squared minus 2x is equal to a negative 3/4. So now I'm going to take that negative 3, or negative 2, divide it by 2, and square it. So negative 1 squared is equal to 1. So that's what I'm adding to both sides. And so I have x minus 1 from what we had inside the parenthesis squared is equal to negative 3/4 plus 1, which gives us 1/4. Now I'm going to take the square root of both sides. And so that gives me x minus 1 is equal to plus or minus a half. Now I need to move the negative 1 away from the x. And so I have x is equal to 1 plus or minus 1/2. And so when I find my two solutions, I have 1 plus a half and 1 minus a half. 1 plus a half is 3/2. 1 minus a half is 1/2. And so my two solutions are 1/2, comma, 3/2. Number 6, we have a number in front of our x squared. So starting off with, we're going to divide everything by 3. And that gives us x squared is equal to 10/3 x plus 8/3 is equal to 0. Now we're going to take and move the 8/3 over to the other side. And so it becomes a negative 8/3. And that moves. So we have a negative 8/3. And so I take that 10/3 and I divide it by 2. 5/3, and I square it, 25/9. I'm going to add that to both sides. And so when we add these, I need to take and convert this into the common denominator. So it becomes 24 negative 24/9, because I multiplied both of those by 3. And so on my right-hand side, I have a 1/9. On my left-hand side, I have x, and then I use whatever's in this parenthesis with this middle sign, so plus 5/3 squared. Next step is to take the square root of both sides. And so I have x plus 5/3 is equal to plus or minus 1/3. Now I'm going to move the 5/3 over to the other side. And so x is equal to negative 5/3 plus or minus 1/3. So when I do my two things, negative 5/3 plus 1/3 is equal to negative 4/3, and negative 5/3 minus 1/3 is equal to negative 6/3, which is negative 2. And so my two solutions are negative 2 and negative 4/3. So the next type of solutions that we will have are the irrational solutions. These are the ones that are going to involve a square root. And so when we have these, you're going to do it the same process you've been doing. So the first step is get it to where you have these two terms on your left-hand side and the other on your right. So we need to move that negative 21 over to the right-hand side by adding 21 to both sides. And so that gives me x squared plus 16x is equal to a positive 16. So now we need to take and complete the square. So we need to take and finish up the box. So we take 16 divided by 2 and we square it. And that gives us 8 squared, which is 64. So plus 64 to both sides. And so when I add the 64 to both sides, it ends up creating on the right-hand side an 80. On the left-hand side, we have x, and whatever this number is here is what's going to go next. So x plus 8 squared. Now we're going to take the square root of both sides. So when I take the square root of both sides, I end up with a x plus 8 on the right-hand side. Now, with the 80, I have to think of what is the square root of 80? What perfect square lives inside there? Well, the largest perfect square that lives inside of it is 16. So square root of 16 times 5. So square root of 16 is 4, so that's 4 square roots of 5. So plus or minus 4 square roots of 5. Now we need to move the 8 to join everything on the right-hand side and get that x isolated. So we have x is equal to negative 8 plus or minus 4 square roots of 5. And so when we write our solution, we don't have to find the two individual answers because we're not going to the decimal. And that's the answer. So number 8 is a little bit different. They've already got everything moved around, and we have only the variables on the right-hand side, or on the left-hand side, and our number on the right-hand side. So that next thing we look at, this one actually has a number in front of my squared term. So that means I need to divide everything by that number. And so that gives me x squared minus 10x equals 23. So I'm going to take that 10, negative 10 divided by 2, and I'm going to square it. So that gives me negative 5 squared, which is 25. So I'm going to add 25 to both sides. And so when I do that, I'm going to go ahead and factor this trinomial on the right-hand side, or left-hand side, excuse me. And I have x, and then this number here, so minus 5 squared is equal to 48. So now I need to look inside of 48. So if I look inside of 48, is there any perfect squares that live inside? And so you have the square root of 16 times the square root of 3. And so 4 square roots of 3 is what that was simplified to when we take the square root of both sides. And so we have x minus 5 is equal to plus or minus 4 square roots of 3. Now I need to move my 5 to the right-hand side. And so I have x is equal to a positive 5 plus or minus 4 square roots of 3. And I'm write it in set notation. So 5 plus or minus 4 square roots of 3, and I'm done. That's your answer. So now, let's look at 2 more of these type. And so when we look at 9, what's wrong with 9 is we don't have just our x's only on the right, on the left-hand side. So we need to move that 31 to go to the right. So when we do that, it becomes a positive 31. And on the left-hand side, we have x squared minus 6x. Now to figure out what we need to add to both sides, we take negative 6 divided by 2, and we square it. So that gives us a negative 3 squared. So negative 3 times negative 3 is a positive 9. So I add 9 to both sides. That gives me x minus 3 in my parentheses on the left-hand side, because it's wherever this number is here, goes with the x. And on the left-hand side, that's our left-hand side, and on our right-hand side is 40. So now I take the square root of both sides. So inside of 40, when I start trying to picture what are the perfect squares that are inside of that 40, well, the only perfect square I can find inside of the 40 is a 4. So 4 square roots of 10, so that's 2 on the square root of 10. And so my left-hand side is x minus 3. My right-hand side is plus or minus 2 square roots of 10. I move the 3 to the right by adding 3 to both sides. Those can't combine. And so I have x is equal to 3 plus or minus 2 square roots of 10. And so my solution is just that. Now if I look at 10, I'm going to do the same idea. But we got to add the 57 to both sides. So when I add the 57 to the right-hand side, I end up with 144 on the right-hand side. And we have 2x squared plus 4x. Now I need to get that number away from in front of the x squared. So I need to divide everything by 2. And so x squared plus 2x is equal to 72. So I'm going to take that 2 and divide it by 2 and square it. And so that gives me 1 squared, which is 1 that I'm adding to both sides. And so my parenthesis is x plus 1 squared. On the other side, I have 73. So when I take the square root of both sides, there's nothing I can simplify out of that 73, so I have x plus 1 is equal to plus or minus the square root of 73. Now I need to take and move that plus 1 to the other side by subtracting 1. And so I have x is equal to negative 1 plus or minus the square root of 73. And so if I write it in set brackets, negative 1 plus or minus the square root of 73. So the third type of solution that you could end up with are your complex solutions. These are the ones that have an I involved with them, because we have a square root of a negative number. And so let's look at 11. On 11, we see that we need to move the 43 to the right-hand side. And so it would put a negative 43 on that right-hand side. And so we have x squared plus 12x. So now we need to find what number am I going to add to both sides. So 12 divided by 2 and square it. So that's going to give me 6 squared, which is 36 that I'm adding to both sides. So when I add that 36 to both sides, on the right-hand side, I end up with a negative 7. On the left-hand side, I go ahead and factor that, and so I have x plus 6. Take the square root of both sides. And when I take the square root, it automatically gives me that plus or minus. So we have x plus 6 is equal to plus or minus I square roots of 7. Because we have that negative number that came out, and when it comes out, it's an I. Now I need to move the 6 to join the right-hand side. So I would subtract 6 from both sides. And so x is equal to negative 6 plus or minus I square roots of 7. So when I write it in set brackets, and that's your answer. So number 12. I need to first move that 97 to go to the right-hand side, so it'll be a negative 97 when it's on the right-hand side. Because when you cross that equal sign, it changes its sign. And so now I take the negative 18, divide it by 2, and square it. So that means I have a negative 9 squared, which is 81 that I'm adding to both sides. And so that gives me a negative 16 on the right. And when I factor the left, I have x minus 9. Take the square root of both sides. And I have x minus 9 is equal to plus or minus, the square root of 16 is 4, and we have an I because it's negative, so plus or minus 4i. I now need to move the 9 to the right-hand side by adding 9 to both sides. And so we have x is equal to 9 plus or minus 4i. And so when I write it in set brackets, 9 plus or minus 4i. That would be your solution. So on number 13, we have an issue where we have our x's not on the left-hand side and our number constants not on the right-hand side. So we need to switch directions. So when we cross the equal sign, it changes the sign. And so when we move the 16x to go ahead and join the 4x squared, it becomes negative 16x. When we move the 76 to go over to the right-hand side, it becomes negative 76. Now I need to divide by what's in front of 4. Or in front of x squared, which is the 4. And so that gives me x squared minus 4x is equal to negative 19. So I'm going to take that 4, that negative 4, and I'm going to divide it by 2 and square it. And that gives me 4. Because we have that negative 2 squared. So I add 4 to both sides. And so I have x minus 2 because of what was inside here. And negative 19 plus 4 is negative 15. Now I'm going to take the square root of both sides. And on the left-hand side, that gives me x minus 2. And on the right-hand side, all I can do is bring out that I. So I have I squared roots of 15. But I can't forget that plus or minus sign. Now I need to add the 2 to both sides. And so x is equal to 2 plus or minus I square roots of 15. And so our solution set, we don't have to simplify it any further. And that's our set. So number 14, we have the 80 on the left-hand side that needs to move to the right. So we're going to subtract 80 from both sides. And so that's going to give me 3x squared minus 6x is equal to negative 84. Now I need to divide everything by 3 because that's in front of my squared. And so I have x squared minus 3x is equal to a negative 28. And so now we're going to go through the process for each of these things. So I take the 3, excuse me, that gives me a 2 here. And so I take that negative 2, divide it by 2, and square it. So what I'm squaring is negative 1. So I add 1 to both sides. And so I have, when I factor it, it's going to be x minus 1, because that's what's in the parenthesis here, squared is equal to negative 27. So now I take the square root of both sides. And then x minus 1 is equal to, when we simplify this, inside the 27, a perfect square of 9 lives there. So the square root of 9 times the square root of 3 was 3 square roots of 3. And it's imaginary, so it's plus or minus 3i square roots of 3. Now I need to add the 1 to the other side. And so I have x is equal to 1 plus or minus 3i square roots of 3. And so I write my solution set, 1 plus or minus 3i square roots of 3. And that's your answer.